All right. Hello, Saumil. I think it's mute.
Unmute, unmute. Yeah. Hello, hello all. Good to see you, Marco. Good to see you all.
All right. What time is on your side?
It is 2:30 p.m. I have just had my lunch, and I actually forgot to have my coffee after lunch, but I'll still power through.
All right. Good for you to be here. Thanks for being with us with no hat.
It's a pleasure.
I think what you have done over all your career is impressive. So I'm very sure what you have to share with the rest of the team here will be very beneficial to the community and to all the people interested in security. You might know Saumil. He runs over. He does a lot of things, but what he's doing lastly is to run a training on security, going from ARM exploitation to everything. Basically, you can tell more about this if you want. So if you really want to grow your understanding of how things work in detail, you really want to check out what Saumil does, and very much appreciated what you bring to all the security community. Thanks a lot. All
Thank you,
right.
Marco.
So the
Um,
stage is yours. Feel free to introduce yourself and share whatever you want. I would say you have how much what time we have? 40 minutes, 45 minutes, something like this. So
okay.
it's up to you. And after that, we will have a short, I would say 10 minutes, maybe Q&A using our Slido web app. So you attendees may want to check out how this Slido works so you can interact with our speaker. Okay, I would say ready to go.
Ready to go?
Good
Okay,
luck.
great. Thank you. Thank you, Marco. Thanks, No Hat, for giving me the opportunity to open up the conference. Before I go into the talk and I go into talking about cyberspace and all, I first want to recognize the great contribution that folks like Marco and the No Hat crew do to the cybersecurity community. Like, over the past 20 years, I've started off with small conference. We've gone to like really large conferences, but the beauty is in these smaller events because that's where you get close to people. That's where you interact one on one. We are all the same. We're cut from the same cloth. There is no difference between us. And it is events like this which I cherish the most, value the most. And this is also where I learn. So I would have loved to be with you folks in person. That's an experience which is not replaceable. But I'll do the best I can being with you folks over here. And I look forward to working more in person with you folks going ahead. Okay, my talk, I will very quickly get to it because 40 minutes is not too long of a time, and there's, of course, a lot of things to say. I will apologize to the next speaker, Excel, in advance. I mean, she's awesome, and I hope she understands if I creep onto 5 minutes of her time. Right on. My talk is titled Humans in Cyberspace. It's a fancy title given to basically 20 years of my own observations as to, where things are going. Um, I would introduce myself as, the accidental entrepreneur. I've been trying to run a company for the past 20 years. Somehow it's working. And I call myself an old schooler now because I've been doing this since close to 21 years. Okay, enough of me. Let's get to the talk. The talk is essentially broken down into 4 sections, but they're all interconnected to each other. I mean, first I want to talk about evolution because it's very important to see where we've come from because that defines where we're going to go ahead to a greater or lesser extent. And then I want to parallelly point out a few points of asymmetry. And it is this asymmetry which is kind of causing a lot of imbalance in the world today. And we need to recognize it to be able to figure out, where the next swings are going. We're certainly not at an equilibrium space. I don't think we're going to be there in the near future. We want to see where things are going to swing. Then, of course, we're going to talk about the core subject itself, which is cyberspace. A lot has been talked about cyberspace. We've all lived it. But these are just some of my observations and my views on cyberspace, which I want to share. And last but not least, we're all InfoSec professionals, and we are operating in a space where we are missing the key ingredient that we should be operating upon. And this I come to the conclusion after reflecting upon myself, what I have been doing as a cybersecurity researcher, what I have been doing as an entrepreneur, and what is missing for all these 20 years of my career, and that is trust. So first and foremost, let's talk about evolution. No discussion on evolution can happen without respect to the founding fathers of evolution. In my case, there are two. The gentleman on the left, you know all very well, Charles Darwin, the indirect founder of the Darwin Awards, which are rather funny, but they're rather morbid and true. The gentleman on the right, I am directionally challenged, so I'll call right and left inappropriately. But the other chap with the glasses, his name is Gordon Moore, and he is the founder of Intel Corporation. He also has an award to his name, which is not as morbid as the Darwin Award, and also not as funny. But the two differences between the Darwin Award and the Gordon Moore Medal: Darwin Awards are awarded posthumously, Gordon Moore medals are awarded within the lifetime of the recipient. Okay, we all know what Darwin did, but let's talk a little bit about what Moore prophesized. 1965, just in the early days of Intel, Gordon Moore proposed Moore's Law. And that's been something that is driving technology for all these decades. Moore's Law was simple, that essentially computing power will double almost every couple of years, costs being the same. And this led to an exponential curve in the growth of technology. Today, we are all very familiar with how exponential curves work with this corona thing going on around the world. So I don't need to explain how exponential growth is. But what Moore's Law has led to is a very distinct power asymmetry. We all know that oil was the power currency of the 20th century. In the 21st century, data is the power currency of the world. But there are two fundamental differences that we really need to recognize between oil and data. Oil, you have to extract it from the earth. And when you spend oil, it's gone. It does its work and it's over. So if you want to keep accumulating power, you have to get more and more oil. Either you do that by digging holes into the earth, or you do that by invading a country which has a lot of oil. Whatever, I'm not an oil guy. But data is very interesting as a concept, because you don't have to mine data. I mean, you don't have to extract data from the earth. Data is all around us. We pick up data. But the beauty of data is data generates more data. Data, if it is used, will create more data, and that data will give you more data, and will give you more power, and with more power and more data, you get more data, and so on and so forth. It kind of just like multiplies by itself, and your power keeps increasing asymmetrically. And let's see what type of power shift we've been talking about. This is about 16 years, 17 years of history. I was very fortunate to have good friends in high places. This gentleman in the picture is a dear friend of mine. He and I, went. We lived in the same hometown. We went to school pretty much in the same time together. We met at a community science center, and we both got into programming and all that during our early years. Right? And Dr. Srinidhi Vardarajan, he became a professor at Virginia Tech in the US. And what he built was Virginia Tech System 10, which was the third fastest supercomputer in the world in 2003. It made the top top 500 supercomputer list at number 3. But there's couple of amazing things about his supercomputer, and what made it so damn special is that he clocked a benchmark of 10 teraflops, 10 trillion floating point operations per second, for less than $10 million. And this is because he built his supercomputer out of the first 1100 Power Mac G5s that Apple actually ever produced. What you got on the market was the 1101st G5. The first 1100 straight went to him. and he clocked like 12 teraflops on this network of 1100 commercially available Macintoshes running System 10. He had to build a very special gigabit Ethernet connect because there was no gigabit Ethernet in 2003. So he got the InfiniBand guys to create the interconnect. But he ran his supercomputer out of commercially available hardware and software. The price point to build such a supercomputer would easily be $100 million. And he demonstrated he could do this in a tenth of a cost. But that's very interesting. I mean, that's 17 years ago, right? You may build supercomputers, and supercomputers are used for like really, really fancy applications. Stuff that you and I cannot afford to compute. Stuff like, weather predictions, stock markets, missile trajectories, and all sorts of simulations that go on. It requires this room full of computing. But if we go to this year, we have the NVIDIA Xavier, right? It's a machine which is about smaller than my iPad. It's about 4 inches by 4 inches large. This machine has 512 cores and 64 tensor cores. This thing clocks at 11 teraflops, as fast as Srinidhi's supercomputer. The cost for this machine, I looked it up on Amazon, it's about $1,600 US. Now, what this means is that we have the supercomputing capabilities of 2003 present on everybody's desktop today. I think pretty much vast majority of us, if we want to do high performance commuting back then, we couldn't afford the supercomputer, but now we can afford a $1,600 NVIDIA. The question is, what does this mean in terms of capabilities that the world has? And we can explore that. And interestingly enough, 2007 is a year of milestones, I consider, on many, many sorts. The first milestone is, this is when I had a personal realization after discussing with my father, who is a hobby electronics. Like, my father's built all his circuits using transistors, like guitar amplifiers and whatnot he used to build in the 60s. And I started, I'm not an electronics guy, but whatever electronics project I started with the Arduino. And what it came out to be is that, the microprocessor is the new transistor. It is as small and as cheap as a transistor 40 years ago. And now, when you start building out electronics, you have the capabilities of 1 billion transistors available to you at 2 cents a piece, 2 cents per chip. And 2007 also saw the birth of several evolutionary technologies. They had all matured, because evolution doesn't mean like you create a new product. Evolution means, is the environment ready to support that new fantastic idea that you have? We all have fantastic ideas, but somehow the environment is not capable of supporting them, and they fall flat and they die. But you had evolutionary factors like 3G, small computers which could be powered very effectively by batteries. You had GPS. And with all these technologies, the iPhone, not only could it become a reality, but it could also capture the market because it was usable. It was a device which had the right ingredients, right price point, and it had capabilities that could expand our computing abilities, and people took to it like a stone. We all know what happened after that, right? Society started becoming digital. It was the first step that humans took and truly became the social network. And humans started following two very different paths. In reality, human beings are conservative, more or less private, safeguarded. But in virtual space, humans started sharing everything about their lives on social media. We want to show off, we want to show ourselves, we want to get likes, and we're, bragging and hyping everything up. We're trying to become thought leaders and all that stuff. Like, we started showing off full tilt, and it has not stopped yet. But the other evolutionary factor that I want to talk about is autonomy. And that was also born out of the same components as what was required to create the iPhone. And the first autonomous device also started taking off around that same time frame, which we know as the drone. Now you may say that, oh, the drone's nothing new, right? Why did it take till like 2007? We had radio-controlled airplanes, we had radio-controlled helicopters. Everybody was doing model RC flight stuff. What's so special about the drone? Well, first of all, the technology to do high-performance flight calculations did not exist until the ARM processors became sufficiently powerful. And why is it the ARM processor that mattered? Because the other processors which are powerful consume too much electricity and too much energy. The ARM processor was the first which could perform at a high capacity and could be powered off with a battery small enough that it doesn't add weight, and the damn thing can fly. And then it can be self-guided using GPS and controlled using high bandwidth cellular technology. And that's what made the drone possible. And ever since then, machine autonomy has evolved kind of behind the scenes. But let me show you what the latest and greatest of commercial evolution is. I do not know about military evolution. We're not at Westworld yet, but what we have isn't very far. And here's a demonstration of a Boston Dynamics robot doing some. This thing's doing stuff that I can't do. Like I can't jump and bounce and tumble like this. I'd break my bloody neck. But this thing can do it for years and days to come, as long as it is powered by a battery. Right? With such capabilities, let's kind of connect. Let's just add 2 and 2 and see where we can go with this. Right? What if you add guns and artificial intelligence to this thing? Break Newton's laws, not Newton's laws, break Asimov's laws of robotics, and we have RoboCop becoming a total reality today. We'll talk about AI in a little bit, but AI is kind of getting to scary boundaries, and we all know it. Even the world leaders are starting to have debates about how AI should be used ethically and all that. I'm not going to add to that, but what I want to illustrate is how did AI become so capable, right? Now, AI has a long history. We've always talked about AI since the 80s, and every time there's a breakthrough, we say like, oh, wow, machines will start to think, except that every decade it has had a crest, and then it has had like a trough of disappointment, like it doesn't really stay. Except this time around, right, the AI is definitely sticking. So the difference is all the past decades, the AI was trained in a lab. With this decade, AI is trained with real data, and that's why it's kind of winning. And where did this real data come from, right? The real data came from, of course, the internet. If we talk about the evolution of the internet, right, in the 90s, it was all the beginning of the World Wide Web. Very quickly, we started doing business on the web. We came up with, web components and Web 2.0. And at this point, in the early 2000s, society and technology both embraced virtualization. In technology stack, the virtualization led to the evolution of the cloud. But in the social stack, virtualization led to the evolution of social networks. Both of these put together will form cyberspace. And on top of it, there is a lot of data being generated from both these technologies. In 2007, we started creating processing environments to collect and process big data. And this is still going on. If you want to see what type of data we have today, there's a statistic. The statistic is slightly old because it was taken in February 2020. But if you take all the data on the internet, it totally amounts to 44 zettabytes of data. These are like several zeros too many for my brain to think. But the beauty about all this data is that 90% of this data has been created only in the past 2 years. So if we do this statistic again at NOHAT 2022, all this 44 zettabytes will only become like 10% of the data. We'll have like 440 zettabytes to deal with. This is the speed at which the data is growing, right? But where the hell does all this data come from? What makes this data? This is all our data. This is the data you and I are saying. These are photographs, these are messages, these are videos, these are the 1 billion WhatsApp messages that Indians send every day in the morning to one another, right? This is our data, this is our life. And what happens is this data is free for us as users, but we're paying for it. Who's going to store and carry this data for free? Said no one ever. Right? This data is actively being used in the evolution of artificial intelligence. And what we now see as machine learning, the two patterns that are emerging, one is we voluntarily train the machine, one like, one click, one share at a time, to which point the machine is now very easily able to recognize photographs without any additional training. But there are gaps where the machine is not trained, and then there are sinister programs like the nefarious Google reCAPTCHA, which will force you to teach the machine stuff that it doesn't know. And you have to solve this, otherwise you don't get these services. This is like, if there is an ugly dark pattern on the internet, it is reCAPTCHA. And this is forcing you to teach the machine by crowdsourcing it. It's learning really, really fast. We'll take a slight diversion over here. We're going to now talk about the evolution of cyber attacks. We're all very familiar with cyber attacks. I'm not going to spend too much time about it. But attacks have also evolved. Back then when we joined this whole game of, offensive security, we did it for the laws. Right? We did it so that we could demonstrate the weaknesses. And if we demonstrate the weaknesses, we had this naive view that the world is going to fix it and improve the quality of software. But something somewhere went horribly wrong. If we see the evolution of attacks and money, you see it's all about monetization of cyber offensive capabilities. Right? We went from making money out of DDoS, making money out of spear phishing, making money out of ransomware, to now making money by controlling populations. And let me give you a little money quiz here. What do you get if you combine Windows with Bitcoin? What you get is ransomware. So the concept of ransomware is not new, right? The concept of ransomware has been around since 2000. This is when Ophir Arkin made the first, the first kind of thought discussion. Like, can we not have a virus which will, lock up things and force people to, take certain types of actions? The problem was the monetization. The monetization wasn't there. With the evolution of cryptocurrency, the monetization problem has been solved, and therefore ransomware all of a sudden became reality. Right? Now, if we fast forward the tape from 2002 to 2012, both these pictures, the old, this one and this one, were both actually taken in Singapore. The same people coincidentally got together. Meet Halvar, the Grug, Dave Itel, and SK. If we looked at exploit development in 2012, right, we don't have any new bugs coming out to Packetstorm or Technotronic or whatever it is. All of exploit development, all of offensive security had become commercialized, weaponized, and heavily politicized. Now, if we spend a lot of times talking about the new 0 days and all that. Like, screw 0 days. Let's look at some old bugs, right? Here we have an array of hardware bugs, row hammer, spectre, and meltdown, right? Ask yourself this question: have we really fixed them? Or we're kind of ignoring them because they're not a reality, and some people have issued patches and these auditors check these compliance boxes. You have been patch checked. Yeah, tomorrow if a specter attack happens, if it happens en masse, we will not be surprised. The only reason why these bugs are not being used is because there are easier bugs to use to compromise people than these advanced hardware bugs. But tomorrow these may very well get used. Similarly, like 2015, I did a talk about Stegosploit as an exploit delivery mechanism. It was one of my most misunderstood talks ever. I did not know, what kind of a shitstorm something like this could create, but hey, it was fun. So Stegosploit is not an exploit. It's basically delivering any exploit using pixels on an image using a browser. It just makes use of certain properties that browsers have today. This type of exploit delivery mechanism is invisible even till date to most of your inspecting and signature-based or rule-based detection capabilities. The thing is, has this even gone away? No, we're not seeing active use of this, but this is still around. The truth is that we as an industry have kind of trained ourselves in the community to always look at InfoSec as a knee-jerk reaction. For every problem, there has to be a patch or a hot fix or a bug fix. This is not the case. The truth is there will be vulnerabilities, and we just have to learn how to live and operate within the space. The epiphany behind this statement came to me in a very unique concept, a concept which I read in an architecture blog. It was a concept that the author had termed as Nakatomi space, where Bruce Willis can go up and down in the die-hard Nakatomi Tower at will. He could access any point of the tower without using the intended means of traversal. So he will not use the stairs, not use the elevators. He'll use air ducts, air conditioning shafts, fire exits, elevator chains to go up and down and do pretty much anything he wanted. Now, the truth is, Nakatomi space very, clearly applies to all complex systems today. You cannot have a building without air ducts. You cannot have a building without, thermal heating pipes and all that. Similarly, if you take today's complex software system, there will always be these gaps, these pieces of Nakatomi space that attackers will be able to latch on to. Call it encoding data into pixels, call it, hammering bits and bytes in RAM cells, call it, predicting timing attacks, call it, picking up vibrations of keystrokes from your monitor screen by just looking at variations in light. All these attacks, which were once science fiction, have been demonstrated to be possible today. And we do not have any means of protecting against them. We just have to live with it. In terms of defense, I want to talk about, we go back to 2001. I want to talk about what started the whole thought process of defense. But there were very quickly two timelines that forked in the year 2001. Both of these timelines led to a very incorrect approach to cyber defense because none of us knew it. We all looked at a very knee-jerk, immediate solution type of situation. Like this problem came immediately, therefore the solution has to come immediately. The first timeline, led to the evolution of a new species, which my friend Halvar Flake calls the mitigator. It's a slew of exploit mitigation technologies which started and hasn't stopped yet. Just keeps on adding layer and layer and, keeps on raising the bar higher, but it's not going to stop the root cause of the bug. The second timeline was kind of a more dangerous narrative. It all started when Microsoft started getting hit with a lot of worms, the Code Red and NIMDA and all that. And that gave Microsoft a bad name, to which Bill Gates wrote his very famous trustworthy computing memo. And Gates got the right idea that, if people cannot use our computers with trust, then it's just not going to work out well. But Gates' idea, while it's being right, the approach that the Microsoft execs took was very wrong. So Microsoft took a very threatening approach, and this was Black Hat 2002. I was present at that time in the room where all the bigwigs got together, the Foundstones and the Gardens and the Stakes and all the big folks got together, and Microsoft threatened them, like, what, if you publish your research like this, we're going to stop doing business with you. We're going to cut off your consulting business. So everybody said, yes, sir, we will shut up. No more security research. And for those first few years, as the industry was growing, as the cybersecurity industry was growing, the vendors were really cracking down hard upon researchers. Case in point, the harassment of Michael Lynn, Cisco Gate. Cisco flew in a boatload of lawyers, tore out all his presentation pages, and prevented him from presenting at Black Hat 2005. He still presented, and it was a whole shit show and whatnot. But to fast forward to 2009, it got to a point that researchers were fed up, and they said, like, you know what, no more free bugs. Screw you guys. We're not going to share the research with you. We'll do what it pleases. And therefore, what happened is this led to the rapid growth of the cybersecurity black market. The black hat industry started getting a lot of money. The exploit trading markets were set up, and they're still flourishing. A so-called, there's been many perversions to the whole bug bounty scene and bug acquisition and whatnot, which I'm not going to talk about over here. But what happened is the research went more towards the black areas. Enterprise started adopting security as a risk reduction metric. So, buy products with blinking lights and dashboards, which will reduce our risks. But all the products that you see on the shop floor of any exhibition space today are only based on rules, signatures, and updates. And sometimes a little bit of machine learning thrown in to get more venture capital. But these things are very short-lived. They don't work well. They work to stop the latest attack only for a short time, and then the attack's pattern and the attack changes. Okay, so with this, let me get into the main area. With this backdrop, we're going to talk about cyberspace. The cyberspace is kind of unique. To me, it's like a planet superimposed on an existing planet. And as we explore cyberspace, we as explorers always want to go to a new planet. You always want to find out, what kind of laws of nature and physics operate there. Well, the one conclusion is very clear, that nature's laws do not apply in cyberspace. And oddly enough, neither do your governments. No matter how much the government say it's regulated, it's still the reckless wild, wild west, where if you shoot the sheriff, you become the sheriff. That's what it is. It's a dark forest out there. We saw in cyberspace military capabilities growing thanks to the burgeoning rise of the military digital complex. And who are the power exerters in today's cyberspace military digital complex? These are companies like Stratfor, which one of their documents published, which is available, is the playbook to isolate the radicals, cultivate the idealists, and educate them into being realists, then co-opt the realists. This is how to win the war against grassroots activists. These are Stratfor strategies. These are think tanks. We have the NSO group, which famously will sell exploits to anybody who's willing to pay prices. And these prices, of course, are old. These are 2018 prices. You can probably double them up to get an estimate of current prices. We have, of course, the new search engines like Palantir, which the US ICE uses to round up people into cages. And then you have the companies which will guarantee you wins in an election simply by changing the thought needle of an entire population, one person at a time, one influencer at a time. So if we were to kind of, figure out what, as I said, like, okay, what passport do I carry? On the face of it, I carry an Indian passport. But which of these flags controls me is a question to us. Who am I being ruled by in cyberspace? Whose rules do I have to comply to? I will not call these flags as governments or republics, because governments and republics have due process and they have governance. These are just flags set up by board members. Board members' governance, constitution, whatever you call it, is nothing else but to improve shareholder value. And they'll do what it takes to bump up that stock price by 1 point at a time. If we talk about the three properties, like the laws, the laws of nature, basically the laws of biology, the laws of physics, and laws of chemistry, I present to you my three laws of cyberspace. Number one, the law of biology, which says that cells equals pixels. The cell is the smallest unit of life, smallest biological building block we have. A pixel is the smallest the cyberspace building block we have. And in cyberspace, cells and pixels are indistinguishable. Basically, this is why phishing attacks succeed. This is why we have, when you enter cyberspace, you have basically no capability with all these millions of years of human evolution. All the capabilities that biology gave you for threat detection will fail in cyberspace. You go for a hike in the forest, you start hearing a growling noise, your brain will react, fight or flight. You know a threat instantly, and you'll be able to take defensive action right there. But here in cyberspace, you'll be facing a phishing site and still be interacting with it until that bear eats you up completely. And what is common sense in reality is ignorance in virtuality, and you actually see human beings behave in two completely different ways. That the same human is very different in reality, very different in virtuality. You want to know more about how human behavior is modified? Read this paper titled Computerization, Discretion, and Freedom by Sergey Bratis, Anna Shubina, and their colleagues. The key statement made here is computers modify our behaviors related to discretion, professional autonomy, and ultimately moral choice. I'm going to take up some more time over here if you folks don't mind. If we talk about how our lives are, we are now living in a continuously distracted world where we have stopped being able to recognize the environment around us. And what is worse is we've stopped being able to think originally, because there is no time for thinking left. You're bombarded with these things, and your mind goes from one distraction to the next, only to be distracted by what's coming up in the future. The laws of physics in cyberspace can be summed up with this one statement: as cyberspace distorts reality. A concrete case in point I'll give you: I was actually flying to see a solar eclipse in the southern part of India last year. Met a passenger along the way and got into conversation, and she realized that we're interested in all these celestial phenomena and all. And she sent me a photograph with this on WhatsApp, saying, "This is beautiful and you'd probably appreciate it." And the text says that this is a day called the Moon Hunters, where there are two suns which are emerging. One is the moon and one is the sun. The only place I know which has two suns is the planet Tatooine, and I have not yet gone there. But the person who was sharing with us was not stupid. She was actually a very smart person. The thing is, she had no background in this area. And if she wanted to dig the facts, it was going to be a long time consuming process before she could process the facts and figure out that this is fake. But instead, if you kind of believe it, you just forward it and spread it. So yeah, we're back to the age of miracles. We had this very short gap in Earth's history between the time that the camera was invented, between the time that the photograph was invented, where the Earth saw no miracles at all. We're now back into the age of miracles with full force. And now we also have an evolution of expert to support the miracles, right? We no longer believe the words of leading scientists. We believe the words of our aunties on Facebook, who have a louder voice and projection than us. And this kind of leads to reality is like you'd think this is a Wile E. Coyote comic, or somebody builds a rocket and blasts off into space to prove that the Earth is flat. Except that this really happened. Well, the Earth was not flat, but Mike Hughes, who built that rocket, got flat because that rocket crashed to the Earth with him in it. It's on YouTube for you to see. I mean, if it's on the internet, it has to be true, right? This is what fueled it. So, coming to this, you kind of have this whole bullshit asymmetry where if you are confronted with bullshit, if you want to refute that bullshit, it's going to take you 10 times the amount of energy to counter it. But instead, the source that is giving you bullshit will just keep on spewing bullshit. And this is something that we'll all have to reckon with in cyberspace. We don't know the defense yet, but we're going to figure it out. And I used to do a thought experiment with my audiences. I did this in a real talk as well. Like you see all these pictures in your social network, and we as human beings have certain cognitive biases. We will tend to passively associate each photograph with what type of person they are, without us realizing it. This is how our brains have been trained. So if I would ask the audience, saying, who do you think is the mountaineer in this whole group? And they'd either say that it is the lady in photograph 1 or the person in photograph 5, or who is, the professor of literature at Harvard, and they'd probably point to photograph 3 or photograph 8. A journalist would be a toss-up between photograph 6 and photograph 7. Like the new tech bro would be photograph number 4, and so on. Our mind is already figured out who these people are without any background, just by seeing these pictures. And if any of these people, like if person number 4 makes a statement about the growth in technology, you will believe it. If person number 3 makes a statement about something in economics, you'll believe them. If person number 6 makes a political statement, you'll believe them. But the truth is, this person does not exist. These are all fakes. These are all generated by neural networks. If you go to this website and refresh it, you'll keep on getting these fake profiles. And this leads me to the law of chemistry in cyberspace. You don't know if you're interacting with a carbon-based life form or a silicon-based life form. In cyberspace chemistry, carbon equals silicon. They actually, ironically, both have 4 electrons in their outermost orbit. They form the same type of lattices. And in reality, these two cyber ghosts were detected after many years, after almost 2 years of interacting with public community. None of these people were real, but they were still being able to influence people in the real world. They believe them and take actions as what these people would direct them to. So with the rise of supercomputing capabilities, with big data, real-time processing and everything, if we want to talk about where we're going next in terms of capabilities of AI, well, here we are. There is this story in Indian culture called the story of these 4 students, who all of them were, very bright. 3 of them were brighter than the 4th one. And these students were, they were trained by their guru. They got a lot of special powers and all that. And once they were crossing a forest, they came across the bones of a dead animal. One student said, I can put this skeleton together with my powers. The second guy said, I'm smarter than you. I can put the flesh and bones of this skeleton on this animal as well. I can recreate it. The third guy says, I'm the smartest. I can make this animal come back to life. And the 4th guy said, you people don't know what you're doing. You're nuts. This is ridiculous what you're trying to do. And these 3 smart people attacked the 4th student, saying, you are the dumbest of the lot. You don't know many things. Why are you stopping us from using our knowledge powers? Sure enough, the end of the story is quite easy to figure out. The lion comes to life. That one guy, the dumb guy, ran away. He lived to see another day. And these 3 chaps became breakfast for the newborn lion. So with all these technical innovations that the folks in the FANG companies are putting together, and us, we'll be putting that lion together one piece, one byte, one like, one project at a time. The day this land comes to life, run. Right. Next steps of evolution, I don't need to tell you where we're kind of heading. If we go there, watch Terminator, watch The Matrix, you'll figure out that this is no longer science fiction. Few predictions for cyberspace in the 2020s. The dawn of the 3Ds, deepfakes, deception campaigns, and digital destabilization. News media's days are over. Nobody trusts the news anyway. News media end up becoming a victim of its own greed. They took too much money from people who paid them, and they're no longer reporting accurate news. And therefore, all of news media's days are going to be just over, no matter, even if there are a few good ones left. And yeah, Robocop, like unmanned armed forces and unmanned civilian law enforcement, are going to become quite real. So yeah, reflect upon a very Orwellian truth that if we continue down this path, we may be headed to a point, to a very Orwellian future. We're not there yet. We're going there. I'm going to start summing up in just a little bit. If you want to figure out how we got there, right? What happened? Where did we take the wrong turn at Albuquerque? This was a statement that Haroon told me. The answer lies in this one statement, like, yeah, what's the difference between Apple and Google in the sales model, right? Apple sells to you, Google sells you. So if you're not paying for the product, you are the product. That's the statement. And today, users are being monetized. We were being sold back then by targeting. We were being profiled and pinpointed and marketed to. In 2020, the money is not in advertising and marketing anymore. The money is in changing your opinion. You are being influenced. If you want to pay a company big dollars, the company will say that, hey, look, I can make all these red boxes turn to the same green boxes in terms of thought patterns. I can convert all of them from red to green, and they will be able to influence the change and correct and track it in real time. So the business now is in assured outcomes, and this is happening on large scale at this moment. And as an industry, technology or cybersecurity, we are to blame. Instead of taking on the mission to protect our users, we monetize them. We did not view upon them as users. We viewed upon them as wallets with money. And we started creating technologies to extract more money out of them. We did not focus upon the problem that exists between keyboard and chair. And these were two tweets from the Grug and SP, where they were talking about user hardening efforts have barely made any progress compared to software hardening efforts over the years. And this is true because along with all cybersecurity people, me included, we used to view users as not being capable of making the right choice. And sadly enough, we only looked at a narrow spectrum of users which were incapable and which did stupid things. But we extrapolated this statement into a one-size-fits-all. We started viewing all users as being incompetent and incapable, and that was a gross mistake we made, a mistake if which we do not correct, a mistake if we do not restore the trust. We are not going to be able to make it as a healthy cyberspace population. Now, when it comes to restoring trust, the fundamental mistake you can make is to try and correct a technology problem using more technology. This is a theorem that I invented, where the solution to any problem lies in a distinctly different space than the problem space itself. If a problem is brought about by excessive use of technology, do not try to solve it by adding more technology. If a security vulnerability is created by code, do not add more code to fix it. In fact, you should only subtract code. But there are, 4 areas of trust which I want to talk about The first one is transparency. The second one is resiliency. The third one is matrix, and the fourth one is trust. But transparency, we need to really, this is a classic example of how we as cybersecurity practitioners need to think about non-technical approaches to create security. Classic example, this was demonstrated by Halvar Flake, right? We all know bank statements. Why does a bank need to give us a statement? Well, the bank is giving us a statement to kind of demonstrate transparency. Like, this is your record. Here it is at a glance. And with this, you can check your accounts. You can, check your spending. You can reconcile the accounts, and you can detect any errors if they may have happened. And they will provide you with an opportunity to, discuss or debate or rectify these type of errors. But with these statements, you kind of are earning the trust of your bank and the trust that transactions are being taken care of. This is kind of giving you that peace of mind that, yes, I can use the bank systems and they're healthy enough for me to do business with. Halvar's discussion, he posted it on his blog. Beautiful stuff, right? Why cannot we have a bank statement for app activity? Why cannot an operating system make visible all the stuff that these apps are doing, and then we as the user demand action from Facebook and Google and Instagram and WhatsApp about, hey, why the hell are you turning on our mic all the time? Or why the hell are you syncing our contact books 80 times a day? What's going on? Only then will some healthy stuff come out. Let us think about taking a non-technical concept, implementing technology around this, and therefore elevating the level of trust. Second of all, if you want trust, you have to trust the user. And you have to put the user in control. Today, all the technology we created eliminates users' control. We decide to control it and we push it onto the user. Like, why do you want to make rockstar users change their passwords once every month? Like, this is nonsense. Leave them alone. They're outperforming you. This, by the way, is my user maturity curve, where I now regroup users into hopeless, uninformed, proactive, and rockstars. Basically, there's nothing you can do about hopeless. Leave them alone. Screw them. You should not be doing anything about the rockstars because they're doing better than what you expect. Learn from them. Proactive users are doing as well as you expect. Don't fiddle with them. Don't monkey around with them. But instead, what you should do is take the uninformed users, work upon educating them with one concept at a time, and make the shift. Pretty soon, you'll realize you'll shift the curve to a very desirable level. Now, there's some examples that were given, like one of our banking customers decided to implement this technology based on our suggestion. Like, you have your banking ATM debit cards, right? By default, these cards are blocked. If you want to unblock them, you have to send an SMS to unblock the card. Then you walk up to the ATM, make the transaction, and then you block the card again with an SMS to block and unblock. This puts the user in control, and this gives the user assurance that, my card is blocked and I control this. I can choose when to unblock, when to block. And as a bank, if you're looking at, which user is making proactive use of this technology, they're already on the path to maturity. Start thinking about innovative, trust-generating solutions like this. There are other applications like Telegram or Gmail or WhatsApp. They will let you see where other logins have come from, and they will even let you log out if they detect anything unusual. Put the user in control. There's several examples of that. The other thing I want to say is, please, it's 2020. Let's do away with passwords once and for all. It's too much time, has too much energy, and too many auditors are making a living out of, debating about passwords. Passwords are shit. We have technologies which you're using these days, like WhatsApp Web. You simply aim your camera, your phone camera at the QR code, and you will be logged in. Like, why cannot we make use of cryptography like HOTP and TOTP and make it universal? It's been there, tried and tested. What's keeping us from doing this? We've got to take ourselves out of that box. So to kind of summarize the 4 elements of security: This is what we really, really need to focus on. Like I said, transparency, metrics, resilience, and users. We have come as a cybersecurity industry from a culture of resistance. We've always fought with everything. We've always pushed back. And that's why we also get pushback. Nobody really wants to, implement the things we're saying because we're always tangled. But the truth is we're fighting with our own selves. We're fighting with users like you and I. You know, if you talk about who owns cybersecurity in an organization, it's a game of passing the buck. Like, I don't own it. It's not my job. It's not my job. It's not my job. If you look at the technology, it's all these boxes with blinking lights, rules, signatures, updates, and patches. It's all reactive. We are all incurring technical debt by bringing on the next short-lived security product and then have to babysit it forever, whereas it is not really being effective. For users, we've encumbered our users. We've forced them to upgrade. We've forced them to change passwords. We've forced them to do this, forced them to do that. And as cybersecurity practitioners, we have become fear mongers, whether we know it or not. We have become people who are in the business of selling fear. But instead of a culture of resistance, where we fight with our own selves, we have to go to a culture of resonance, where we look at the same picture, you and I, we come to a same combined vision, where we all take ownership for the security. We don't do pass the parcel. We don't bring on the next short-lived security products. We will build defendable systems. We will put security and trustworthiness as core software features of what we do, keeping all the four principles of trust in mind. Instead of encumbering our users, we will empower our users and enable them to make the right decision. And instead of selling fear, we have to enable trust. So that is my concluding concept that I present to you. And to do all this, there is no secret ingredient. We just have to believe in ourselves, just like what Kung Fu Panda did. With this, I end my discussion. Thank you very much for your time. Thank you, Excel, for putting up with me. Apologies for eating into your time. Thanks. I'm done.
I'm not sure if you can hear me, but man, amazing. Like, I think you should. I mean, I'm super happy. If it's fine for you, we will put your keynote on YouTube. And you've been in the industry since ever. So I really like the photo of 20 years ago with Harvard. All the other guys were cracks. So I mean, it's like the history of security worldwide. So yeah, I mean, if you are like in university, I guess you have to watch this video once. I mean, to understand where you come from. We have so many students that they get passionate into security, but they really don't know what's behind. So it's the kind of things that they should teach in the university. So you should have like a course dedicated to this, or even in a company. If you are a company that have some security values, they should watch your YouTube keynote here. I mean, this is what I believe, right? So if I would be like a chair of my own company, I would go and say, okay, you guys, you have to watch this video to understand where we come from and what will be in the future. So I have actually tons of questions, but time is always a problem here. So I guess people can reach out to you in case they have additional questions. And
should I just go to the room and wait for the questions, or you tell me what to do? I'm available. I'll be happy to answer questions online, offline, on Twitter, whatever you want.
Well, you can go. Yeah, you can check out on the Inslido to see if people want to make a question right now. Otherwise, they can easily ping you over Twitter or whatever. So I guess we are anyhow all connected. And yeah, looking forward to see you in person maybe next year. I hope there will be some in-person conference. and we can talk more of all the problem you raised. I mean, there are solutions, but there are so many problems, and we really need people to get interested into security to be able to address all the concern you raised, like the huge amount of data stored online, the password that are still used everywhere. I mean, there are so many still open challenges, so it's very, it's great for us to be in this area of work, in my opinion. Okay, good. If you want to say something to your audience, I give you 1 more minute.
Thank you very much for your time and attention. Thank you, Excel, for putting up with the little overflow that we had. I am eagerly waiting to join your talk, and I'm tuned into the conference. Thanks again, all of you. Stay safe and mask up.
Enjoy the rest of the conference, man.
Yeah.
There are a few interesting talks coming up, so some of them really fall into your area of interest, especially the technical one. So I'm sure you can enjoy the rest of the day.